Hello, my name is Steven, and in this video I'll be discussing air sampling using the Air or Combo Moldlab Pro Kit. Air sampling is not particularly difficult to do, but there is a lot of nuance to taking the absolute best samples possible and correctly interpreting their results. Don't worry if things seem complicated. I'm going to be going into a lot of detail on a number of different topics that will only affect your results by a little bit. If you just want a step-by-step walkthrough of the sampling process itself, you can jump to the Air Sampling Instructions section of the video timeline, or read the written instructions below. If you still feel overwhelmed, you can always start by just using surface sampling, which doesn't require nearly as much nuance or any special sampling equipment. If you're still with me, I'll start going into the details of where and how to take the best possible air samples. Before taking your samples, you'll need to decide which building conditions to use while sampling. Typically, you'll want to use closed house conditions wherever possible. This means that exterior windows and doors should be closed for at least 12 hours prior to beginning your test. Normal entry and exit of the building is not a problem, so long as doors are not left open for an extended period of time. Vents, such as stovetop fans and bathroom vents, should be used as little as possible during this period, and HVAC systems should never be used while there is a concern of airborne mold, as this can spread mold spores throughout the home. Testing under closed house conditions will cause your air samples to contain as few spores from outside the home as possible, leading to a more isolated picture of what's going on within the home. The alternative conditions you can test under are called normal house conditions. These are exactly what they sound like. Your customer behaves however they would normally behave, with doors and windows open however much they normally keep them open in the lead up to your inspection, and fans run as they would be run on a typical day. Keep in mind the HVAC system should still not be run unless absolutely necessary. Testing under normal house conditions will lead to your indoor air having more similarity to the outdoor air than testing under closed house conditions, which can make it more difficult to interpret your results. However, it will also give a better picture of what the air in the home is actually like on a typical day. Both methods of testing are valid, but we recommend using closed house conditions where possible, as it will make your results easier to interpret. Either way, make sure to write down in your inspection notes which set of conditions you sampled under, as this will be very helpful to you when interpreting your results. For your next step, you'll need to choose where you'd like to sample. Air samples give a snapshot of what the air quality is like in a particular area at a particular time. They're very useful for finding mold in cases where there is nothing visible. However, a low level of mold is a normal part of our air makeup. There are some spores in the air all the time. As there are no established safe levels of mold, you should always take an outdoor sample along with your indoor samples. This outdoor sample will serve as a reference or a baseline. When you get your results back, you'll compare between your indoor samples and your outdoor samples. If the indoor air has the same or lower amounts of mold than the outdoor air, that is generally considered a normal or acceptable result, especially for an initial inspection. As homes typically have an HVAC system with a filter, the indoor air sample should ideally have substantially lower amounts of mold across all mold types. We'll talk more about interpreting air results near the end of this video in the report section of the timeline. When taking your outdoor air sample, choose a location that is reasonably close to the building where you'll be taking your indoor air samples. However, make sure you're far enough away from any open windows or doors to prevent indoor air from mixing with your outdoor sample. Taking a sample right next to an open window, for example, can cause your sample to not be representative of what the outdoor air is normally like in an area. We typically recommend being at least 10 feet away from any doors or windows. For an indoor air sample, choose rooms that have been identified as concerning. For example, take samples in a basement, a bathroom that has been flooded, or a bedroom with a musty odor. This will give you a good idea of exactly what is in the air at a particular area at a particular time. When you have multiple affected rooms, it's a good idea to sample each area that is significantly separated from the others. Consider how isolated each area is in terms of the HVAC system, walls, and doors. The more separated two rooms are, the more valuable it is to sample each room. You may also want to sample areas that are commonly occupied. Discuss with your customer their concerns to help determine which rooms are the most important to sample for their peace of mind. Finally, if you still have air cassettes left over, you can consider sampling an unaffected room. This will provide you with a second point of reference to help you interpret the results you receive from areas you expect to be affected by mold. In each room you intend to sample, choose an appropriate spot to sample. Generally, the air cassette should be around 4 to 5 feet off of the ground at normal breathing height. You usually want your sample to be representative of the air that people will normally be breathing, so consider sampling near the area someone is most likely to spend time, or in the area of the most concern. Also consider the airflow in the room. You don't want your cassette to be directly in the line of a vent or fan that is on during testing. If no spot seems better than any other, just take your sample near the middle of the room. Next, I'll walk through actually taking air samples. Begin by marking on the sample a number matching the test kit form. Write a description of the location you'll be sampling from on the test kit form on the corresponding numbers line. This will allow us to match up the correct sample to the correct location when we receive your samples in the lab. Decide how long you would like to take your sample for. If you're unsure, we generally recommend a 5-minute sample for most environments. The vast majority of the time, a 5-minute sample will get results that you can use. Here are the full manufacturer recommended sampling intervals. We've also marked the most common sampling intervals other inspectors tend to use for each type of sample. Pause the video if you'd like to review them in more detail. Next, you'll need to get your air pump ready. There are a wide variety of air pumps on the market, but most of them are similar to one of the two pumps I have to show to you today. Pumps like this Thomas Mega-Lite must be plugged into the wall and use 1/4 inch inner diameter plastic tubing to connect to your cassette. This pump has a manual flow rate control using this black dial and has an attached rotometer. Other pumps, such as the Bioaire, allow you to attach your sample directly to the pump and are battery operated. This pump has a digital flow rate control and comes with a separate rotometer to measure the flow rate. I'll begin by showing you an example from the Thomas Mega-Lite. Once I'm done with that, I'll proceed with an example from the Bioaire. You can jump back and forth in the video timeline below to see an example from the pump that's most similar to yours. However, if you're not using one of these two pumps, it's a good idea to refer to your pump's manual to make sure that you're using it properly. First, I'll discuss the Thomas Mega-Lite pump. Step 1. Attach plastic tubing to your pump nozzle. The other end of this tubing will attach to your cassette. Step 2. Turn on your pump and allow it to run for 1 to 5 minutes without a cassette attached, so the flow rate can stabilize. You'll be able to tell that the flow rate has stabilized because the sound of the pump will be consistent and the rotometer will be steady. Step 3. Remove the top and bottom quality seals from your samples and put them somewhere safe. You'll need them again when you're done sampling. Step 4. If you're using a tripod, pass the plastic tubing through the eye hole. Now attach your cassette and start a timer immediately. If you aren't using a tripod, set the cassette down on a flat surface such that the open face is not obstructed. Step 5. Adjust the flow rate of your pump to 15 liters per minute using this black dial. The center of the bead on your rotometer should be on the line. This is the recommended flow rate for the air cassettes provided with your kit. Bear in mind that bumping or moving the pump may change the flow rate. The flow rate is also affected by the presence of the cassette, so it's important to adjust the rate after the cassette is attached. Step 6. Once 5 minutes, or your desired sample time, are reached, turn off your pump and stop your timer. Write down the exact start and stop time for your sample onto the test kit form. Step 7. Disconnect your cassette from the plastic tubing. You don't need to remove the plastic tubing from your pump. It can be reused many times. Step 8. Replace the quality seals on the top and bottom of the cassette. Step 9. Place the cassette in the return mailer. Move your pump to the next sampling location. Step 10. Repeat steps 2 to 9 for each sample you wish to take. Don't forget to take one sample outside. Your results will be difficult or impossible to interpret without one. When taking your outdoor sample, make a note of the weather, as rain, wind, and other conditions can affect your outdoor result. Now I'll give an example with the Buck Bioaire. Step 1. Remove the plastic plug from your pump and turn on your pump by pressing the on button. Ensure the low battery LED is not lit. If it is lit, you will need to charge your pump prior to sampling. Sampling while at low battery can lead to improper flow rates. Step 2. Press the Cal button to turn on calibration mode. Allow the pump to run for 1 minute to stabilize. You'll be able to tell that the pump has stabilized because the sound of the pump will be consistent. Step 3. Remove the top and bottom quality seals from your samples and put them somewhere safe. You'll need them again when you're done sampling. Step 4. Push the cassette firmly down into the sample fitting until it fits snugly. The small circular side should be down, with the wide open face up. Start a timer immediately. Step 5. Place the rotometer on top of the cassette and push down firmly. Step 6. Adjust the flow rate by using the up and down arrows until the center of the ball in the rotometer is at the 15 mark. Press the Cal button again to accept the setting. Remove the rotometer. Bear in mind that bumping or moving the pump may change the flow rate. The flow rate is also affected by the presence of the cassette, so it's important to adjust the rate after the cassette is attached. Step 7. Press one of the time keys to take an automatically timed sample, or press the on button for 4 seconds to manually time the sample. Your sample time should include the time that passed while calibrating the pump with the cassette attached. Step 8. Remove the cassette from the pump and replace the quality seals on the top and bottom of the cassette. Step 9. Write down the exact start and stop time for your sample onto the test kit form. Step 10. Place the cassette in the return mailer. Move your pump to the next sampling location. Step 11. Repeat steps 3 to 4 and 7 to 10 for each sample you wish to take. Don't forget to take one sample outside. Your results will be difficult or impossible to interpret without one. When taking your outdoor sample, make a note of the weather, as rain, wind, and other conditions can affect your outdoor result. Finally, we'll look at an example air report. The first page displays the test kit form you sent us, as well as some information about the lab and test methods. The second page is where the results are. Each sample appears with the number and location provided from the test kit form. There is also a volume in liters listed for each sample, which is calculated based on the run times you provided on the test kit form and the 15 liters per minute recommended flow rate. On the left is a list of all mold types detected across all your samples, and below each sample are the exact quantities detected. The left raw column is the number of spores physically counted on your sample. The right S/M3 column stands for structures per cubic meter. This is the calculated concentration of spores based on the 15 liters per minute flow rate and the times listed on your sample form. At the bottom of each sample are totals for both raw count and the concentration, as well as a debris field rating. This debris field rating has nothing to do with the amount of mold present in your sample. Instead, it indicates the amount of non-mold debris present in your sample, such as dirt or other particles. All indoor air samples provided with the kit are shown on the left side of the form. The outside comparison sample is shown on the right for easy reference. This layout is also used in the bar graph at the top, which provides a visual comparison between the total fungal concentrations of the samples. Samples that have a higher concentration of a particular mold spore than the outdoor sample will have that concentration highlighted in yellow. If the concentration is 10 times higher than the outdoor sample, it will instead be highlighted in red. This color coding is here to help you quickly identify the most prevalent mold spores. At the bottom of the report, some additional technical information is provided in regards to the test method. When comparing between indoor samples and the outdoor sample, the goal is usually to determine whether or not the indoor air sample can be considered elevated. If an indoor sample has an elevated result, there is usually a mold source causing that elevation. To determine this, compare each mold type individually. It is generally preferable to compare the concentrations rather than the raw counts, as the concentration takes into account differences between microscopes, cassettes, and sampling times. If two samples were run for different lengths of time, it is completely impossible to compare them using the raw counts, and you must use the concentration. If they were run for the same period of time, it may be possible to compare the raw counts between the samples, but it is still not recommended. You can also compare the totals between samples, which will give you an idea of the overall amount of mold in a particular area. However, even if the total for a particular sample is much lower than the outdoor air, if an individual mold spore is elevated in comparison to the outdoor air, the sample is still generally considered elevated. In most cases, just seeing a higher concentration of spores on the indoor air sample than on the outdoor sample is sufficient to conclude that the indoor sample is elevated and that there is a mold problem in the area. However, if the difference between the indoor air sample and the outdoor air sample is small, it's worth considering a few additional factors before finalizing your comparison of concentrations. Consider the debris field ratings of the two samples. The higher this rating is, the more difficult it was to analyze your sample due to a negative mold bias. With a high debris rating, mold spores could be obscured on the slide by the debris. Additionally, mold spores may have bounced off of the sample entirely because they impacted onto the debris rather than the adhesive inside the sample. For example, the true amount of mold that passed through a moderate debris field rating sample could be 33% greater than reported. On the other hand, the true amount of mold that passed through a trace debris field rating sample should be no more than 5% higher than reported. Keep this bias in mind when comparing samples with different debris ratings, especially debris ratings that are very far apart from each other, such as trace and heavy. Next, consider the weather's effects on your outdoor air sample. Rain commonly causes fewer mold spores of most types to be present in the outdoor air, but increases the amount of basidiospores dramatically. High wind can also reduce the number of spores in the air, and doesn't usually favor any particular mold type. If these conditions changed shortly before you conducted your inspection, they may have affected the result of your outdoor sample and not had time yet to affect your indoor sample. In cases such as these, experience is extremely valuable in being able to interpret the effects of the weather on your outdoor air sample. If you don't yet have enough experience to make these sorts of determinations, this can be a very good reason to call us and use some of your consultation. Bear in mind that small fluctuations in mold concentrations are expected throughout a house. A difference of a few hundred concentration between locations is usually not cause for concern in and of itself. Finally, realize that some mold spores are inherently more concerning than others. While many mold spores are commonly found in the outdoor air, some are almost never found in an indoor sample without an associated mold problem. Stachybotrys and Chaetomium are two mold types that will cause many mold inspectors to immediately conclude that there is a mold problem, regardless of how much of these spores are present. Now we can move on to the next report section, the glossary. This section lists each identified mold type from the report and provides some information about it. Classifications, health effects, appearance, and environment are discussed for most mold types, along with example images of the mold under the microscope where available. However, any health concerns should always be discussed with a physician. The health effects of mold are not well understood, and the science on these is constantly evolving. Additionally, Moldlab is not a medical laboratory, and we do not have physicians on staff. The final section of the report is an FAQ, provided to help you understand some common concerns brought up by previous customers. There is also an FAQ for the test kit overall, available below this video. Once you've received your report and looked it over, you're welcome to give us a call with any questions you may have. Again, remember that you're limited to 10 minutes of phone consultation per kit, so it's a good idea to review your report thoroughly before you call. If you need other information about the kit, check the other videos and instructions on this page. If you're still unsure, give us a call. We'll be happy to help any way we can.